Okay, so we've talked about some of the special features of arteries. We've talked about some of the special features of arterioles. We've talked about some of the special features of capillaries and how capillary exchange takes place. That moves us into these vessels known as the venules. And the venules, the smallest veins, the only thing interesting and exciting about them is that they join together and form larger and larger veins. So, done with venules. Let's talk about the veins. Veins, as we discussed when we were looking at the structure of vessel walls, have a large lumen, a large opening, and their walls contain smooth muscle, but not very much elastic. And what that means is that it's very easy if you put more blood in a vein to get that vein to stretch. You've perhaps seen this on your own body. If you fall asleep with your arm underneath you and then you look at the veins on the back of your hand that are all sticking out now because they're full of blood. Veins are like very stretchy balloons. And the purpose of being stretchy or distensible is to allow the veins to act as a reservoir for blood. A reservoir is a space where we hold extra of something, just like a water reservoir that serves a community. When extra rainwater comes, the reservoir is where we hold that and collect it for when we need it, when it's not raining. So the veins hold a great deal of blood and can easily, by constricting, send more blood into the rest of the circulation, or by dilating, can hold on to that extra blood until it's actually needed in circulation. Veins also have these structures, which we've seen before in the heart, called valves. And that's important for getting blood to return to the heart, which we'll talk about shortly. Perhaps, if I can get the slide to change. All right. Okay, let's take a look just so that you can see where the blood is distributed in the circulatory system and how the veins hold so much. Let's take a look at this pie chart. This is all of the blood that's in circulation. So the entire 5 liters or 4 to 6 liters. These numbers are not important for you to know in any way. This is just meant to illustrate where the blood is positioned in that circuit at any given moment. So only about 12% of the blood in circulation is in your heart at any given moment in time. Your heart is not designed to hold blood. It's designed to push blood through. So we expect this number to be low. About 20% of the blood in circulation is in the pulmonary circuit, meaning it's either on the way to the lungs to get oxygen or it's on its way back from the lungs to be sent out to the body. The remaining 70% of the blood is in the systemic circuit, which is a much larger circuit that serves a great deal of organs. And if we look closely in the systemic circuit, we can see that the blood in the arteries is not very much. In fact, it's comparable. This is the systemic arteries, pardon me. It's comparable to what we see in the heart. So the arteries are not holding that much blood at all. Their job, remember, is just to deal with that high pressure and keep it moving so that that oxygen-rich blood can reach the tissues. About 5% of the blood is in the capillaries conducting exchange at any given moment in time. And that leaves more than half of the blood in the body in the veins on its way back to the heart to go through the circuit again. This doesn't mean that each circuit pumps a different amount of blood. This simply means that there is more blood in that circuit at any given moment in time. Now, veins have the lowest pressure of any of the vessels. This makes sense because substances only flow from high pressure to low pressure unless we do work. So the highest pressure in the vessels is in the arteries because it's receiving blood directly from the contracting ventricles. As the blood moves through the arteries and the capillaries back to the veins, the pressure has to continually get lower. If the pressure in the veins were higher than the pressure in the capillaries, then blood would flow backwards and would defeat the whole purpose of circulating. We can see that in this graph too. This is showing the pressure in different blood vessels as we move away from the heart. So you can see that the pressure in the aorta is higher than any of the other vessels, and it's also fluctuating as the ventricles contract. And as we move into smaller and smaller arteries, that pressure drops. Pressure drops as we move away from the heart. Otherwise, we wouldn't move away from the heart. When we get to capillaries, the pressure is already quite low. But as you can see, as we cross over into the veins, the pressure continues to drop and is at its very lowest. So it reaches the lowest point right before it reaches the heart. And the heart is the only thing that can move blood from low pressure to high pressure. And it does this by using energy and contracting. So it has to work against the gradient. It requires energy to move against the gradient. Well, most of our veins, if we're standing up, are below our heart. So we need a way to get this low pressure blood from our feet and our legs and our hands and our arms back to the heart. And without having the benefit of having another heart down in our feet that's pumping to get the blood back up. The process of getting blood back to the heart is called venous return. So what that means literally is that the blood is returning to the heart through the veins. Now, there are a number of mechanisms that help the blood to get back to the heart. One is the pressure gradient that we've already been talking about. If this is low pressure and behind that is higher pressure, then there is always pressure pushing the blood back to the heart. But that's actually not enough, as we'll discover, especially when we start talking about circulatory shock. One mechanism that's very important for getting blood to return to the heart is called the skeletal muscle pump. And that's what we see here. So in this is an image of, let's say, a vein in someone's calf. And the muscles, the calf muscles that run alongside the veins or that the veins run between. Here you can see the valves inside the veins. And these valves only open when the blood is flowing up or in the direction that I'm moving the cursor. When blood tries to go back down, the valves close and it prevents the backflow of blood. That's what's happening here. Gravity is pulling the blood down because the pressure in the veins is so low. It's not like having a ventricle pushing it through. And the valves prevent it from going all the way back down to your feet. So it's a little bit like a ladder. The blood climbs one step at a time to reach the heart. This happens to be a ladder that we get some assistance with. When these muscles contract, the muscles become thicker and shorter, just like when you contract your biceps muscle and you see that bump where the muscle is contracting and becoming thicker. The same thing happens with any muscle as it contracts. It becomes thicker. And because it's becoming thicker, it presses on the walls of the vein, that particular segment of the vein that we're looking at. This is a lot like having contraction. except that the vein's not doing it itself. There's an external muscle that's contracting and creating the higher pressure inside this segment of the vein. If the pressure is high enough to open the valves, then the blood will pass through to the next segment where the valve will prevent it from going all the way back down. Meanwhile, other muscles help to push blood back into this segment, and the next time those muscles contract, it will help the blood to move back towards the heart. So that's the skeletal muscle pump. And to give you a sense of how important it is, if you have a job where you're standing, say, at a cash register all day and you're not walking around a lot, um, the blood will actually pool because the skeletal muscles aren't contracting enough. And what that will often lead to, and those of you who have had this kind of job will know exactly what I'm talking about, is that your feet will be painfully swollen at the end of every workday because the blood is actually pooling down in your feet in the lower limbs. One solution to this, if you're stuck in that kind of job for any period of time, is to keep moving your legs. That way, the skeletal muscle pump is moving the blood back up and it's not pooling in your feet. What else did I want to say? Other mechanisms. So I talked about the pressure gradient. Another mechanism for getting blood back to the heart is called cardiac suction. If you'll recall, when we talked about the cardiac cycle, there is a phase called ventricular filling, and part of that phase is rapid filling. This is where the ventricles begin to relax and finally become lower pressure than the pressure in the atrium, and the AV valves open, and there's such a great pressure difference between the atria and the ventricles that it sucks the blood in. The most blood that, or the fastest filling that occurs of the ventricles occurs then. We call that rapid filling. Well, that rapid filling is helping to pull blood from the veins as well. If we take it out of the atrium, then that reduces the pressure in the atrium and helps the blood to get back into the heart from the veins that are attached to that atrium. So there we refer to this as cardiac suction, the heart sucking the blood in. When we talk about this same phase in the cardiac cycle, we refer to it as rapid filling. It is exactly the same thing. It's just which perspective we're looking at things from. Finally, veins get some help, or I should say some veins get some help from gravity. Usually we're working against gravity when we talk about venous return, but the veins in your head are actually aided by gravity. Gravity is all they need for the blood to return to the heart. And in fact, the gravity takes care of things so well that the veins in your head and your neck do not contain valves, which is why if you flip upside down, it feels like all the blood in your body rushes to your head. There is nothing in your veins to prevent the blood from going backwards, unlike the rest of your body. I think, oh wait, I have one more slide. So those are the mechanisms of venous return: the pressure gradient, cardiac suction, the skeletal muscle pump, and gravity. So all of those things have to work together to drain the blood from the veins back into the heart. Let's take a look at something called varicose veins, which helps to illustrate just how important valves are in the process of venous return. Now, on the right side of the diagram, you see a normal vein with normal healthy valves here. And what's not pictured are the skeletal muscles that are helping to increase the pressure and push the blood through each set of valves as we move the blood back towards the heart. In varicose veins, um, people are born with a genetic defect that causes the valves in the veins to malfunction. They don't prevent the blood from flowing backwards. And what happens is as the blood flows backwards and accumulates in each of the vein segments, the veins begin to stretch because of the increased volume of blood and the increased pressure in the veins. And as they stretch and become even floppier and even floppier, they begin to fold on themselves. So if you look here, you can see this vein's gotten so stretched that it forms a zigzag pattern. And all of that is from the veins being distensible and nothing or not able to get the blood back to the heart. And so it's accumulating in these veins and stretching them more and more and more. Um, People with varicose veins are often wear super elastic socks in order to act like an external skeletal muscle pump, something to squeeze on the veins to keep them from stretching out with all the extra blood. Um, but often, especially in severe cases of varicose veins, surgery is required. Because what happens as the veins grow larger and larger, they hold even more and more blood, which means that less and less blood is returning to the heart. And that can lead to potential consequences in terms of cardiac output. Um, so this is surgically corrected when it's severe. Keeping your feet up and wearing those elastic socks is a way to cope with it on a day-to-day basis. All right, I think that's it for veins.